Hello everybody, welcome to our first take-home STEM experiment. My name is Miss Libby and I'm the children's librarian over at the Glen Rock Library. And I'm so thankful you signed up for this. Hopefully you'll have a really good time. We're going to be doing one of these a month, and each time they're going to be a different subject. In December we're going to have something on forensic science, so keep your eye out for that. Okay, so what are we talking about today? What we're talking about is oxidation. So it's a big word and it sounds very sciencey, but it is something you see all the time. To put it very simply, oxidation is what happens. It's a chemical reaction that happens when you add oxygen to a compound. So what does that really mean? We are going to be exploring an oxidation chemical reaction that happens that you've probably seen before, and that is when cut apples turn brown. So when cut apples turn brown, they look kind of yucky, right? And the reason that happens is oxidation, because the inside of the apple is exposed to the air, which has oxygen in it. So today we're going to be talking about how to slow the process, how to stop the process, and how to think critically about how each of the different liquids will work. Okay, so if you want a more detailed explanation about oxidation, you can look in your packet. There's a little bit more information about that. But I thought we should move right on to the experiment. So let's get started. Okay, so in your bag, you're going to find an apple and two juice boxes, one with apple juice and one with lemonade. Your experiment's going to be a little bit different from mine because I don't have lemonade. What I have is lemon juice. But if you have lemon juice in your house, you can use that too. In fact, you can use any number of liquids you can find around the house. If you do have it at home, I would suggest doing vinegar as another option because it has a pretty extreme reaction. But all you're going to need for what we're doing is your two juice boxes, some plain water, and salt. So what are we doing? We are going to try and stop apples from turning brown. And like we discussed, that happens because air touches the apple. So what are some things that we can do? We can try and stop the air from touching the apple. Another thing you can do to stop the oxidation is to lower the pH of the apple, which is basically to make it more acidic. So if you know a little bit about lemons and citric acid, maybe you can make your prediction there. What I want you to do is get your liquids ready. I'm going to start with the apple juice, but you can do this in whatever order you want. You're just going to need to remember which cup has which liquid in it. So if you have a pen, you can write it down, or just put a piece of paper in front and write down which one is which. For the apple juice and the lemonade, you'll be able to tell, but the water and the salt water, it'll be a little bit harder. So I'm putting about a teaspoon of salt in, but if you want to add more than I am, you can do that. Oh, the salt's hard. If you want to add more than a teaspoon, you can use that as an experiment to compare it to mine. So maybe you want to add a tablespoon. Actually, that's more than a teaspoon. That's about 2 teaspoons. But now I'm going to add water to that and let it dissolve. And my last cup is just water. So I have 4 cups and an apple. Now, hopefully you followed the instructions and have not cut the apple yet. And that is because the apples turn brown very quickly. So we want them to be able to get them in the liquid as soon as possible so this experiment works. Now that we have our juices. Before we cut the apple, I want you to take out your packet and go to the page called My Predictions. So I have a line with each of the liquids you're going to be using today. If you're going to be using more liquids than this, you can flip it around and write down other ones you're doing. But what I want you to do is write on the line whether you think it is going to turn more brown or less brown than the control. So the control is a piece of apple that we're going to do nothing to. We're just going to leave it so that we can compare the other ones. We can see whether it helped or it made it worse, because the control is going to show us what happened when it was exposed to air. Okay, so write down more or less. Think about what we talked about. Keeping air from getting to the apple, lowering the pH, and then after you've written down whether you think it'll brown more or less, I want you to rate them 1, 2, 3, 4. 1 being the one that will turn number 1 will be the most effective, which means the piece of apple will turn brown the least. And then 4 is the one that will be the least effective. So what will be more brown than the others? Okay? So once we do that, it's time to cut our apple. So for this bit, you need an adult because you need a very sharp knife to cut the apple. I'm gonna do it right here, and I haven't done it ahead of time, so you're gonna have to watch me cut it. And that's because, like I said, it turns brown very quickly. Cut this apple, and you're going to need at least 5 pieces. I have very small cups, so I'm going to be cutting each of my pieces in half. But if you have larger cups, you can do a larger piece. Just remember that apples float. So you want to cover the apple with the liquid, but only just to keep it from floating. If it still floats, it doesn't matter. You can always take a look at the side that was face down in the liquid to make your judgment. Okay, so putting 1 in the apple juice, 1 in the lemon juice, 1 in the, whoops, I mixed them up. Do you know how I'm gonna figure out which one's salt water? Okay, that one's salt water. 1 in the salt water and 1 in the plain water. And set this to the side. So once you have that done, it's going to require a little bit of patience, because what needs to happen is the oxidation on the control. And that's going to take a little bit of time. So what I want you to do is pause this video once I finish talking and just let them sit for half an hour. And exactly half an hour, because that's what I'm going to do. If you set it for half an hour, you can compare yours with mine. But if you don't get it in time, that's all right. Just don't compare it with mine. Compare it with only your apples. Okay? I'll see you soon. Okay, so it's been exactly half an hour, and I'm going to check on my experiment. First, this is my control. This is the one we did nothing to. I'm going to bring it up close so you can see. Is it more brown than yours, less brown? In some cases, the lighting may affect how brown it looks, but it's pretty brown. So I'm going to set that here. And now I'm going to start taking my apples out of my liquids. And if you put this on a paper plate, you could always write on the paper plate the liquid it came out of. I'm just going to do it in order so I remember, but I have the control down first. I'm going to take out the one from the apple juice, lemon juice, salt water, and regular old plain water. Okay. Now I'm going to take my phone off of here, so it might be a little wonky for a bit, but I'm going to show you up close what mine look like. Okay, so here are my apples. Now the lighting down here is a terrible fluorescent light, so you're not getting a really good view of what these look like, but control, apple juice, lemon juice, salt water, plain water. I don't know if it's the same on yours, but on mine, the plain water did the worst. Then the salt water, then the apple juice, but the most effective was the lemon juice. You could have different results, especially since you're not using lemon juice, you're using lemonade. And if your lemonade one is very different from my lemon juice one, I'd like you to think about why that would be. Lemonade isn't just lemon juice, right? It has other things in it. So that probably keeps it from being as effective as the lemon juice. Okay, I'm gonna put my phone back up. Okay, so I want you to take out the sheet called My Results from your packet. And without looking at your predictions or thinking about them, I want you to write down what actually happened. This is what makes it science. A lot of times in science, what you think is going to happen isn't necessarily what did happen. And it's never about being right or wrong. It's about the facts. So it doesn't matter if your predictions didn't come true. It only matters what happened. So your results may be different from mine, like I said, but some of them definitely worked better than others, and they all, at least in my case, kept the apple from browning as much as the control. So, why do you think that is? We did one major thing, right? By putting the apple in liquid, we kept the air from getting to it. But it's not just about air. Remember I said lowering pH or making the apple more acidic can help. That is why the lemon juice worked the best, because lemon juice has something in it called citric acid, and it's what makes it kind of tart, and that lowered the pH of the apple, and it did it on two fronts. Made the apple more acidic, and it kept the air from it. So that's why it worked so well. Now you have lemonade with sugar and water in it. So it probably wasn't effective as my lemon juice. And that's actually an interesting thing to note in and of itself. Now, if you did not use vinegar, if you ever want to try this experiment again, I encourage you to try and use vinegar, because something weird definitely happens. I'm not going to tell you what it is, because you should try it out for yourself and do the experiment again. All right, I hope you had a good time with this, and I will see you next month for our forensic science take-home STEM. And I'll also see you around the library. So make sure to say hi. I can always recommend some good science books for you. All right, thank you for signing up, and I'll see you next month. Bye.